Hello there, my name is Vanessa. Today I will be explaining to you about electrochemistry. So first of all, what is electrochemistry? Electrochemistry is a branch of chemistry dealing with the study of the relationship between the chemical reaction and electricity. Electricity can be generated by movements of electrons from one element to another in a reaction known as redox reaction. There are two types of electrochemical cells. First is a galvanic cell or voltaic cell. In this type of cell, energy is released by a spontaneous redox reaction that is converted to an electrical energy. This enables it to directly empower objects such as a light bulb. While in the electrolytic cell, electrical energy is used to drive non-spontaneous redox reaction. Example of applications of these electrochemical cells. The AA alkaline batteries are examples of galvanine cells because the electrons flow from anode to cathode. Anode is the negative while the positive is here, which is the cathode. Anode is negative because it has a negative potential with respect to the solution, while cathode is positive because it has a positive potential. An example of electrolytic cell is the lithium-ion batteries in our smartphone. The flow in an electrolytic cell is from cathode to anode. The anode in electrolytic cell is positive because it is connected to the positive terminal of the battery, while cathode is the negative because it is connected to the negative terminal of the battery. A rechargeable lithium-ion battery is an application of both of the electrochemical cells. It acts as an electrolytic cell when it is being charged by electricity, and acts as a galvanic cell when it is used. This is a good representation of a galvanic cell. So, the zinc here acts as the anode, and it is where the oxidation will happen. Because zinc tends to lose electrons more than copper, there will be a flow of electrons from the anode to the cathode, which generates a current and electrical energy which is used to do work such as lighting a light bulb. The neutral zinc will give up 2 electrons and become zinc ion, while for the copper ion, it acts as a cathode, which will experience reduction because it will gain 2 electrons from zinc and becomes a neutral copper. A salt bridge is also needed to maintain electrical neutrality within the internal circuit. So the overall reaction that will happen will be this. Zinc plus copper ion will become zinc ion and copper. Before we learn more about redox reaction, we should know how to assign oxidation state. First rule is that an element itself or free element has a net charge of 0. For example, is oxygen gas. It's a free element as it has a neutral charge and it is not chemically bonded to other elements, so it will have 0 charge. Next example is a helium gas. It is also a free element, therefore it will have a 0 charge. Second is elements in the family 1A is always +1, except for hydrogen. Example is for potassium chloride. Potassium is in family 1A, so it will have a charge of +1. Next is elements in family 2A is always +2. For example, is in calcium oxide. Since calcium is in family 2A, then calcium will have a charge of +2. Next is point 4 is the sum of oxidation numbers for a neutral compound is 0. Example in potassium bromide, since it is a neutral compound, then the charge of bromide will be -1 because potassium will be +1. Next, point 5 is the sum of oxidation numbers for a polyatomic ion is equal to the ion charge. Example is in a sulfate ion, where oxygen's charge will be -2. Since oxygen's charge will be -2, then sulfur will be +6. So that later we will get -2. We need to multiply the number of atoms with the charge. So oxygen will be -8 and sulfur will now be +6. Next is the charge of monoatomic ion is the ion charge itself. For example, is on sodium ion. Since it has a charge of 1, then sodium will have a charge of +1. Next rule is hydrogen becomes +1 with nonmetals and becomes -1 with metals. For example is on calcium hydride. Since calcium is a metal on family 2A, then it will have a charge of +2, and hydrogen here will be -1, and we multiply it by the number of atoms, so it will be equal to 0. So calcium will be +2. And then another example is on hydronitric acid. Nitrogen is a non-metal, so hydrogen will have a charge of +1. Then we will get nitrogen as -3. Next, point 8 is halogens are usually -1 but becomes positive with oxygen except for fluorine. Example is on magnesium chloride. Chloride is a halogen, so it will have a charge of -1, which means magnesium will have a charge of +2. Next is fluorine is always -1. As stated before, fluorine doesn't apply to rule number 8, as it will always have a charge of -1. Lastly is oxygen is usually -2 but becomes -1 in peroxide. For example, on aluminium oxide. Oxygen will have a charge of -2, while aluminium will have a charge of +3. Another example is on hydrogen peroxide. Hydrogen will have a charge of +1 because oxygen is a non-metal, and oxygen will have a charge of -1. Because this is a peroxide, so this will have a charge of -1 and hydrogen will be +1. So now we are ready to learn about redox reaction. Redox reaction is a reaction in which electrons of an atom is a substance are transferred to an atom of another substance or the same substance. Redox reaction consists of two kinds of reactions, which is oxidation reaction and reduction reaction. Oxidation reaction is a half reaction that involves loss of electrons. In oxidation reaction, there is a reducing agent, which is a substance that carries the atom that has lost electrons. Reduction reaction is a half reaction that involves the gain of electrons. In this reaction, there is oxidizing agent, which is a substance that carries the atom that has gained electrons. Types of redox reaction. First, we have redox as gain or loss of hydrogen. Two things that we have to remember. Loss of hydrogen is oxidation and substance is called reducing agent. Second is gain of hydrogen is reduction and substance is called oxidizing agent. For example, in this reaction, hydrogen sulfide and chlorine gas will become sulfur and hydrogen chloride. Let's take a look at this reaction. So from hydrogen sulfide to sulfur, it shows loss of hydrogen. So based on this statement, it means oxidation will happen. Then in this reaction, it shows from chlorine gas become hydrogen chloride. So that means that it will have a gain of hydrogen, which means reduction will happen. In this reaction, the reducing agent will be hydrogen sulfide because it carries the atom that undergoes oxidation, while the oxidizing agent will be chlorine gas because it carries the atom that undergoes reduction. Next is redox as gain or loss of oxygen. Two important things to remember. Loss of oxygen is reduction and substance is called oxidizing agent. Second is gain of oxygen is oxidation and substance is called reducing agent. Example on this reaction, aluminium and cupric oxide becomes aluminium oxide and copper. In this pair of reaction, it shows that it will show the gain of oxygen, so it means oxidation will happen. And on this other pair of reaction, it shows loss of oxygen from cupric oxide to copper, which means reduction will happen. The reducing agent in this reaction will be aluminium because it carries atom that lost electrons, while the oxidizing agent is cupric oxide. Next is redox as gain or loss of electrons. Two things to remember. Loss of electrons is oxidation and substance is called reducing agent. Second is gain of electrons is reduction and substance is called oxidizing agent. So example on this reaction, ferric oxide and carbon monoxide yields iron and carbon dioxide. To know which reaction will gain or lose electrons, we must first find the charges. So iron in ferric oxide will be +3 and oxygen will be -2. Carbon in carbon monoxide will be +2 and oxygen will be -2. Iron here will be 0 because it's a free element, and carbon in carbon dioxide will be +4 and oxygen will be -2. So now we can determine which reaction will lose or gain electrons. The total charges in ferric oxide will be +1, and which later will be 0. This means it gains electrons as it gets closer to negative. So this pair of reaction will be reduction. The other pair of reaction will be oxidation, because the total charges of carbon monoxide is 0 and it becomes +2. This means it gets less closer to negative, and it means it lost electrons. So it means it will experience oxidation. For this reaction, the reducing agent will be carbon monoxide and the oxidizing agent will be ferric oxide. Now let's learn how to balance a redox reaction. So for this reaction below, silver and nitrate ion yields silver ion and nitric acid. So first we should find the charges to find which reaction will have oxidation and reduction. So silver here will be 0 charge because it's a free element, and nitrate ion here will have a total charge of -1. So since oxygen here will be -2, then the charge of nitrogen will be +5. Silver ion here will have a charge of +1, and nitrogen in nitric acid will have a charge of +2, and oxygen will be -2. And as you can see here, the charge of silver went from 0 to +1, so that means oxidation will occur. And nitrate has a charge of -1 to 0, so that means reduction will happen. Now we'll take a look at the oxidation reaction. So from silver becomes silver ion. We'll have to balance its coefficient and charges. So both of its coefficients are already balanced. Now we have to take a look at their charges. The left side has 0 charges, while the right side has +1 charges. To balance its charges, we will have to add electron on the right side, so that it will also be 0. Next, we take a look at the reduction reaction. Nitrate ion will become nitric acid. Now let's balance the coefficients. The nitrogen atoms here are already equal. Next, we take a look at its oxygen atom. As you can see here, the left side has 3 oxygen atoms, while the right side only has 1. So what we want to do is we add 2 molecules of water, so that the right side will also have 3 oxygen atoms. But now that we have added water, a new element is now introduced, which is hydrogen. There are 0 hydrogen atoms on the left side, but there are 4 hydrogen atoms at the right side. To balance this, we have to add 4 hydrogen atoms on the left side. Now that all the coefficients are already balanced, we'll have to balance its charges as well. The total charges on the left side will be plus 3 because 4 charges here and then minus 1 here will be plus 3. Now, while on the charges on the right side are 0. To balance that, we add 3 electrons on the left side so that the total charges will become 0. Notice that the charges on the left side has 3 electrons here, and the charges on the right side has only 1 electron. We'll have to multiply the oxidation reaction by 3 so that the electrons will cancel each other out. So this will be the oxidation reaction. Now that we found both of the reactions, we can combine them. The electrons will cancel each other, and this will be its final reaction. This is the final reaction. That is all for my presentation. Thank you for listening.